Two questions that we had for homework last night on page 256. They both related to centripetal acceleration / centripetal force. I'll just remind you of a couple of things before we do these two questions here. When an object moves in a circle in uniform circular motion, meaning going at a constant speed, it will experience an acceleration. Now, can anybody explain to me how it experiences an acceleration? It's moving at a constant speed, but yet it's accelerating. Yep. Because of the force to the middle, right. Now, in the end, acceleration is defined as the rate of change of velocity, not the rate of change of speed. So that means that as long as the direction's changing, it accelerates. And you're right, Ben, that acceleration is directed toward the center of the circle. We call it a centripetal. Yeah, centripetal with a P. A little bit later on today, we're going to talk about centrifugal with an F and the difference between those two forces. But the force toward the center of the circle is centripetal with a P. There is therefore an acceleration toward the center of the circle as well. Now, question number one talks about this intake fan of a blade of a jet engine has a mass of 7.50 kilograms. It spins. Middle of the blade has a speed of 365.9 meters per second and is a distance of 73.9 centimeters from the axis of rotation. What's the centripetal force on the blade here? Let's write down some givens in this question here. Mass is 7.5 kilograms. We know that the speed of the middle of the blade is 365.9 meters per second and is a distance of 0.737 meters from the axis of rotation. That's going to be what? Diameter or radius? From the axis of rotation is defined as the radius, right? Not the diameter. It's the radius. Now we're looking for the centripetal force here. We're going to say Fc is equal to m times v squared over r. Okay, m times v squared over r. The acceleration would be v squared over r, so of course force is m times a, m times v squared over r. We're going to say 7.50 kilograms times 365.9 meters per second divided by 0.737. When we get do the math there, it works out to be 1.36 times 10 to the 6 newtons. Make sense? Number two, a 0.021 kilogram pebble stuck in the treads of a dirt bike's wheel. The radius of the wheel is 23 centimeters. We've got to convert that to meters. Here's the force. What's the speed of the wheel? So same question, but we got to rearrange this one. Fc is equal to mv squared over r. Let's solve for v. How do we do that? How do we do that? Let's take the r out by multiplying. F times r equals mv squared. And then we're going to say F times r over m is equal to v squared. And then we're going to say, how are we going to get the v by itself? V is the square root of f times r over v. So or f times r over m. So make sure you do that with the 0.23 meters. When you do that, you should get 8.5 meters per second. That make sense? Okay, let's do one more quick example, and then we'll wrap it up for the day here. Last example here. Example 5.5 on 259 says, determine the max speed at which a 1,500 kilogram car round a curve, radius of 40 meters, coefficient of static friction between the tires and the road is 0.60. And you can imagine if you're an engineer designing a road, this would be a useful calculation to be able to perform, right? What's the maximum speed that you can go around this turn at? We know that as this car goes around a turn, there is a centripetal force, right? And it's equal to mv squared over r. But we know that centripetal force is always caused by something. What's it caused by here? What causes the centripetal force? What fundamentally allows that car to not skid off the road? Friction. So we're going to say that the centripetal force is caused by friction. The centripetal force is equal to friction. Therefore, mv squared over r is equal to mu times the normal force. But the normal force, as long as it's a horizontal road, an unbanked turn, okay, then the normal force is m times g. Agree? Look at what happens here. What do you notice? What's the shortcut? M cancels. So it doesn't matter how heavy the vehicle is, okay, you get the exact same max speed. Now, some vehicles have better suspension than others and so on, but as far as just purely mass, it doesn't make any difference. Now we're going to solve for speed here. V squared over r is equal to mu times g. We're going to take the r up by multiplying. V squared is equal to mu times g times r, and then v is equal to the square root of mu times g times r. So 0.60 times 9.81 times r, which is 40. Solve for v there. Let's pull out the calculator to do this one. 0.6 times 9.81 times 40. Let's square root that. And we end up getting 15.3 meters per second, or 15 meters per second. So what happens if you're going 14? You're going to be going around that turn. You're going to experience quite a bit of g-force as you're going around that turn, but you're going to make it around the turn, right? If you're going at 16, what's going to happen? You're not going to go off in a straight line, because there is still some force pulling you in toward the center, right? But you're going to go off the road. You're just going to go off the road more like, if this is the road, you're going to go off the road more like this, kind of in a curved way. Does that make sense? Yeah. Okay, here's your homework for tonight. Page 259, questions 1, 2, and 3.